Hi everyone. We need to go over the steps of the scientific method. Tomorrow you're actually going to be putting those into use doing some lab work in class. We use a 6-step scientific method process when we do our inquiry labs at the high school. I've seen as few as 4 steps. I've seen as many as 10 or 11 steps in a scientific method. It really depends on where we start one step and stop that step and start the next step. The process really is the same. It's a matter of how we divide it up. So we're going to look at a 6-step method. And what I want you to do is take the notes as we go along, fill in your note sheet. If you've got any questions or you miss anything, you can review and go back a little bit. And we're going to talk about this a little bit at the beginning of class tomorrow as well. So let's get started here. Our first step, we're going to identify a problem. This is often the purpose of doing the lab. I will sometimes give you a problem to investigate, and I'll give you the question I want you to be looking at. Sometimes I'll give you the opportunity to choose the question or choose the problem for yourself. It's really what you want to find out or learn more about. Now, the second step is collecting your research, and this is where you're going to gather information from lots of different sources, as many as you can. It can be very informal in terms of observation. You can do your own little sort of mini tests and collect data. You can also search the internet. You can search using library tools. You can talk to an expert. Make sure that the sources you use, however, are reliable sources. Beware of bias. There's a lot of biased information out there on the internet. You've got to be a savvy consumer of that information. You've got to think about that while you're going through the process. And make sure you keep track of where your information is coming from, because you are going to need to cite your sources. You are going to need to make sure you give credit to the people who have come up with information or ideas that you're using in your research. Our third step is making a hypothesis. This is a possible explanation based on the observations or research you conducted. The idea here is to take the information that you have collected, take the information that you've found out about, and turn that into an explanation that solves the problem. I do want you to get into the habit of writing your hypotheses as an if-then statement. So if this happens, then this is going to happen. Or if this is true, then this will happen. The idea here is to make the wording very concrete. You want to make sure that it's obvious, that everybody knows what it's going to look like if that happens. And if you do a good job of writing your hypothesis, then the testability is very simple. You'll be able to look at that hypothesis and know right away how you're going to go about setting up an experiment to test that. Step 4 is conducting the experiment. You've got to have some sort of experiment that's going to test your hypothesis. It should be written in numbered steps when you write it out. I don't want to see any big run-on paragraphs. I want to literally see number 1, here's what I did. Number 2, here's what we did. It should contain one independent variable and one dependent variable. Independent variable is the part that's controlled by the experimenter. You, as the experimenter, control the independent variable. The dependent variable changes based on what you do to the independent variable. So let me give you an example. If you were testing how sunlight helps plants grow, and your hypothesis was if a plant is given more sunlight, then it will grow better. So we're going to test sunlight, we're going to test how the plants grow in that sunlight. You, as the researcher, are going to control how much sunlight the plant gets. That's the independent variable. How much it grows depends on that light. That's the dependent variable. Whenever possible, you should use a control group. So in my plant example, you want to think about, okay, we're going to have a group that's sitting on the windowsill, a group that's in the dark, a group that's maybe in the middle of the room. That way you've got some different things to look at. You want to make sure that you have something to compare it to. That's the idea of a control group, is a comparison. And then the last part of this, make sure anything else that affects the results is held constant. You only ever want to test one variable at a time. So in my plant example, water, fertilizer, those two things both affect how well the plant grows. So you want to make sure that all of your plants, regardless of where they are in terms of sunlight, that they all get the same amount of water, that they all get the same amount of fertilizer. Okay, once we've done our experiment, we have everything set up, we are going to collect data and results. Data may be quantitative or qualitative. Those are two really big words, but if you break them down, they're pretty easy. Quantitative, if you look really closely, you can see quantity sort of in there. Quantitative data are measurements, actual numbers. I left it in the sunlight for 5 hours a day. I rose the temperature, increased the temperature to 60 degrees Celsius. That's quantitative. If you say it took 10 seconds for the water to reach a certain temperature, whatever. Actual numbers, that's quantitative data. Qualitative data are descriptions. Can you see the word quality in there? These are descriptions like color changes. You may talk about temperature changes based on, it got warmer, it got colder. We're not talking exact numbers, but we're just talking about how the qualities or properties changed over time. A lot of times people say, oh, well, the quantitative data is better, and in a lot of cases it is, but don't ignore the qualitative data. Watching what's happening and changes that are happening, even if it's not something you're measuring, can be really, really important in an experiment. Data always should be displayed in both a data table and a graph wherever possible. I want to see both of them. We're going to do a lot of graphing and graphical analysis in this course. You've got to get used to looking at it in both displays. And make sure that you only are collecting observations and recording observations for this section. Avoid drawing conclusions until the last step. Observations are what you see, what you feel, what you hear, what you smell. Don't talk about why yet. That comes in our last step. The why it smells or why it's happening, that's a conclusion, and we'll get into that in the very last step. And speaking of which, let's head to that one. Step 6 is draw the conclusions. Use the data to determine if the hypothesis is supported. Was your hypothesis correct? How did it turn out? Did it come out the way you expected it to? Why do you think those results turned out the way they did? This is where you not just tell me what happened, but why you think it happened that way. Let me give you a little hint here. The things we do in class have to do with the topics we're studying. So think about what we've been working on and how it applies to the labs that we're doing. Identify any sources of error that may have affected your results. You may not use your lab partner as a source of error. No matter how hazardous that person may be, you may not use an individual in class as a source of error. Sources of error are things that happened, things that maybe you couldn't control, that went wrong during the lab, that maybe you didn't think of ahead of time, that have affected your results. Please do not say that your calculations were wrong, because your inability to do math is really not a source of error in an experiment. Suggest improvements or extensions for future trials. If somebody were to pick up your experiment and do it again, what would you tell them? The second time around, what would you do differently? And there are always things that you can do to improve an experiment or extend an experiment. So please don't tell me everything worked out exactly the way we expected and there's no way we can do it any better. There are always ways to improve, so make sure that you keep that in mind. All right, so just a quick review, 6 steps. We're going to go through all of them tomorrow in class. We'll be doing some open-ended inquiry-based labs, so be ready to go when you get into class.